Hey guys and gals, it's Mr. V. Hey, we are working on a concept here with fractions that's going to really help us when it comes to other skills within fractions. It's going to help us when we start to add and subtract fractions. It's also really going to help us when we start to multiply fractions. So we're really going to need this skill in our back pocket so we know we can use it if needed. Sometimes you'll use it, sometimes you won't. And the skill is getting a mixed number to be an improper fraction and an improper fraction to a mixed number. So we've talked about this a little bit. I've showed it to you a little bit, but I want to better hit this so you truly understand it. Okay, so there's two different ways. There's two different methods. So you can have. Remember, when we're learning our fraction concepts, and real quick, you don't have to write this, but you can just review with me. So we have our 1/2. Remember, this is our numerator. This is our denominator. Numerator represents what we have. The denominator represents what the pieces are cut into. So in this case, we have 1 out of 2 pieces. So we're smaller than a whole. So a whole is 2 pieces, and then I have 1 of them. So I don't have a whole. I don't have more than 1, so I'm good. What we're going to be working on are making mixed numbers and improper fractions. Now, we should know a mixed number and an improper fraction. And again, you still don't have to write this down. This is just review. This is where you have 3 pieces and they're cut in half. So you have 3 1/2s. So that's what that 2 means. That 2 is what the pieces look like. They look like 2s or halves. And you have 3 pieces, but your 3 pieces are halves. So you have 3 halves. So again, if I was going to draw this, every fraction starts out as a whole. So I'm going to draw it. I'm going to cut it in half because that's what my denominator tells me. But it says I get 3. Numerator says 3. So there's 1, there's 2, and I can't possibly make a third one, so I have to have a new whole. So I have a new whole. I got to make it look like the denominator, so I got to cut it in half so my pieces look like 2s, and then I need my third piece. So if you look, you can tell I have 3 pieces over 2, so that's with this fraction. But remember, if I look at my mixed number, if I want to make it, if I want to put the wholes together, how many wholes do I have? I have 1 whole candy bar, and then I have a half of a candy bar. So this is a mixed number. This is an improper fraction, which we also call a fraction greater than 1. We're going to learn today how to go in between them. If I have a mixed number, how do I turn it into an improper fraction? If I have an improper fraction, how do I turn it into a mixed number? Okay. So we're going to start with a mixed number to an improper fraction. So we're going to go mixed to improper. Or remember, that's called a fraction greater than 1. Okay? I like the name fraction greater than 1 because it tells us what it is. He is a fraction greater than 1. Okay? So here's my mixed number. We're going to go pretty easy with this. I'm going to go 1 2/3. Okay? Now, I'm going to show you how this works. First, I'm going to draw a picture. And then once we draw the picture, then I will start to show you a mathematical way. So I'm going to prove it to you. You're going to prove it by a visual that it works. And then I'm going to show you how that visual can be turned into something mathematical we can do. So let's draw this. So I have 1 whole. So I'm going to draw 1 whole. Okay. I'm going to shade it in. I'm going to use my highlighter to shade in so it's not as messy. So there's my highlighter. So I have 1 whole. But it also says I have 2/3 of another whole. So I'm going to draw my whole again. Try to keep your holes the same. But this time it says I have 2/3 of it. So I need to cut it into thirds. That's why it's so important to know what numerators and denominators are. There's my thirds. And in my numerator says I have 2. Okay. So there we just drew 1 2/3. But I need to get it to be an improper fraction. I want it to look like this up here. I want it to be an improper. Remember what we talked about. Improper fractions count pieces. I'm going to write that. We already wrote it down once in our notes earlier. Improper fractions count up all the pieces. And I want you to write that down because that's huge that you know that. So we're going to count all the pieces. Well, when we do that, we could go, 1, 2, 3. That's not correct, though, because these pieces are not the same size. In order to count all the pieces, they need to look the same. So here, we see that the pieces are cut into what? They're cut into thirds. Well, this guy is a whole candy bar. But technically, we can also cut him up. So we got to take this whole and we got to cut him up. And we're going to cut him up into what our denominator tells us. So you always look at the denominator to see what your pieces look like. The denominator says 3, so I cut my pieces into thirds. In doing so, I didn't change the shade. I still get all of those. All I did was, instead of having one whole, now I have how many pieces? 3. Okay, so 1, 2, 3. Now, I have these two over here as well. So how many total pieces do I have? 1, 2, 3, 4, 5. I have 5 total pieces. What do my pieces look like? I have 5 what? Well, my pieces are 1/3. 1/3, 1/3, 1/3, 1/3, 1/3. So I have 5 thirds. So what does that mean? That means 1 2/3 is the same as 5 thirds. So if you draw it and then you cut the holes and then count all the pieces, you're good to go. Okay. Now, there is a math shortcut to it. I won't call it a shortcut. There's just a mathematical way to do this instead of draw visuals. But we're going to do a couple more before I show that to you. So let's do another one. Let's go a little bit bigger. Let's go 2.5. I'm not going to go too huge. So now I have 2 holes. I'm going to draw 2 holes. Okay. I'm going to shade them in. If you have a highlighter, I recommend you use it. There you go. And now I have 1/2. So I got to draw another hole, but I don't get that hole. Remember, denominator says cut it into 2s. The numerator says right there says 1. So there's my pieces. In order to start counting, though, all my pieces have to look the same. Okay, so I got to take my holes here and I got to cut them up. And I got to cut them up to what my other pieces look like. Well, the denominator said cut them in 2s or halves. So I'm going to cut here and here. Notice again, I did not change the shade. I still get the full candy bar. I just cut it into more pieces. So if you count all your pieces, I have 1, 2, 3, 4, 5. So I have 5 pieces. But what do my pieces look like? My pieces are halves. They're cut in 2s. Okay. Now, in order to know this is how the trick's going to work, or the math cut is going to work, just to call it that. Okay. If you look at your denominator is going to tell you how many pieces to cut your hole into. Okay. So when I have 2 holes, right? So these were my 2 holes. When I did that, and I'll even draw it again so you can see it. So there's my holes, right? So there's my holes. You don't have to draw this again if you don't want to, but just pay attention. So there's my 2 holes, right? My denominator tells me what my pieces should be cut into. So when I go to cut these holes into pieces, how many pieces does that give me? It gives me 4. So basically what I did is I took the denominator and I multiplied it by my whole number. Okay? So it's like I put a multiply sign right there. 2 times 2 is 4. That told me how many pieces are in my holes. So when I take the denominator and I multiply it by the whole number, that tells me how many pieces are in the holes that didn't have any cuts before but now do. Okay? Well, I'm not done yet because I still have more to add because I still have this 1 piece left over. So I got to draw that, and then I'm going to shade here. Okay? So there's my 1/2. So then I'm going to add the numerator. I'm going to add the extra piece that I had attached on. And again, if you do that, 2 times 2 is 4, plus 1 is 5. So there's 5. What do your pieces look like? Well, your denominator says your pieces were cut in half, so he never changes. So there you go, is 5 halves. So the mathematical trick to this is you take the denominator, multiply it by the whole number, add the numerator, and you get your answer. Okay, I have a fun little movement for this. So when we are in class, I'll show it to you so you know. So again, you're going to take the denominator because the denominator tells us what? Slow us down. The denominator tells us what your pieces look like. I'm going to times that by the whole number. Why? Well, because what I just did here. Okay, I had 2 holes, right? I had 2 holes, but then I cut them up into pieces because the denominator said the pieces look like 2s. But when I cut the holes into pieces, it gave me multiple pieces. It gave me 4 pieces. The same amount it would give you when you take the denominator and multiply it by the whole number. So the 4 took care of that right there. Then I'm going to add the numerator because the numerator is that extra piece that I have here still. So now I have the 4 pieces from the wholes, the 1 piece from the fraction. So now I have 5 pieces. My pieces look like halves. Okay, let's do another one. And again, I'm going to draw the picture still, but we're going to move more over to the visual or away from the visual. So last one with the visual. So here's my 1. Okay, that's my 1 hole. I'm going to shade him. Okay, and then here's my 1/3. So there's my 1/3. I got to cut them into thirds, and I got to just get one of those thirds. Now, if I want to make a mixed number, or I'm sorry, this is a mixed number. If I want to make an improper fraction, I want to count up the pieces. So I got to take this whole and I got to cut him up into pieces. What do I cut him up into? Thirds. So when I do that, I'm going to take this and I'm going to multiply. I'm going to take the denominator, multiply by the whole number. When I do that, what I'm basically doing is I'm cutting the whole into thirds. Why thirds? Because that's what the denominator told me. When I do that, how many pieces did I just make? 3. The same thing as 3 times 1. Okay, I cut my whole into 3 pieces. Now I'm going to add the numerator. Why? Because I have another piece over here to still add together. So altogether, I should have the 3 from 3 times 1 plus 1 is 4. So I have 4 thirds. Okay, and that's how you would do it. Now let's try to do it without a visual. You could do the visual, but visuals get to be pretty hard to do when your fractions get big. So say I have 3 and 2/5. So again, this would be hard to draw a visual. I could draw 3 holes, and then I have 2/5. So what am I going to cut all my holes into? Who tells you what to cut the holes into? This guy right here. So imagine 3 holes, and I'll even draw the picture, but not cut. So if you watch, there's 3 holes. And I'm going to cut, I'll do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You don't have to draw the picture. I'm just showing you. So there's my 5 holes right there. Okay, so if I shade that all in, how many total pieces do I have? Well, there's 5 here, 5 here, and 5 here. So 5, 10, 15. The same thing as 3 times 5. So the reason you multiply these two numbers is because it's going to tell you how many pieces make up all the holes that you have. So if I have 3 holes, I cut them all into 5 pieces. That's 5, 10, 15. Well, then I have to add the numerator because I have a couple more pieces left. I have this 2 over here. I have him left. And there it is for a total of 5, 10, 15, 16, 17 fifths. Why fifths? Because my pieces are cut into 5s. They're cut into fifths. So that's how it would work. So I backed it up with a visual, but you don't have to do the visual. Okay. What if I have 4 and 1/3? Okay. First thing you're going to do it with me. Ready? Take the denominator. Multiply it by the whole number. Say that with me. Take the denominator. Multiply it by the whole number. Okay. That gives me 4 times 3 is 12. What does that mean? That means I had 4 holes. I'm cutting them into 3 pieces. So I have 12. 3 times 4 is 12. So I have 12 pieces. I have to add the extra piece to make 13. So I have 13 pieces now. What do my pieces look like? They look like thirds. And that's how you would get your mixed number to be an improper fraction. This one's usually the easier of the two. What if I did 7 and 4/5? Let's make it big. Okay, no one's going to want to draw a picture like that. So I have 7 holes, but now we got to cut them into fifths. So I'm going to take the denominator, multiply by the whole number. So what's 5 times 7? It's 35. So that means when I took my 7 holes, I cut them into fifths. I now have 35 pieces. I'm going to add the 4 extra pieces up here to get 39. And then what do my pieces look like? They look like fifths. Okay, so that's how you do that way. The other way is to go improper, or what we call fraction greater than 1, to mixed. This way isn't hard. It's just basically, you'll see it real quick. It's going to be a little bit of division. Okay, so let's start easy. Let's say I have 3 halves. Okay. So basically what you're going to do is you're going to go opposite. So let's draw pictures again to prove it. Okay, so I'm going to draw, and I know every fraction starts out as a whole, and I know what I have it cut into. It's cut into halves. Well, how many halves do I get? How many halves do I have? I have 3. So I need to shade 3. So I'm going to shade 1, 2. Oh, well, I don't have enough. So what do? I got to draw another one. And then I'm going to say 3. So there's my 3 halves. But now, mixed numbers count the wholes, then pieces. So we're basically going to do the opposite. We're going to put the pieces back together to make wholes. So how many holes do I have here? Well, I have 1 whole candy bar, and then I have 1 numerator. What do my pieces look like? They look like halves, so I have 1 and 1/2. The other way you do this is this becomes a division problem. Okay? So you would say, how many times can 2 go into 3? Okay? And we could divide it out. Okay? I don't know if necessarily I'm going to show it to you right now because I don't want that to confuse you. Okay? I guess it should be okay. So we have 3 and 2. Okay? So how many times can 2 go into 3? 1. 1 times 2 is 2, and subtract, I have 1 left. Okay? So if you look, this here is your whole number. This here is the guy left over. He is your numerator. The divisor is always the denominator. And I'll show you that a couple times. Okay? Let's do another one. Let's do 9/4. Okay? So again, I'm going to draw. I'm going to cut it into fourths. I have a whole. Every fraction starts out as a whole. Let me move that up. So what do my pieces look like? They look like fourths. I'm going to cut him into fourths. And how many pieces do I have? 9. So shade 1, 2, 3, 4. So there's only 4. So I know I have more than 1. So I'm going to shade again. Cut him into fourths. I'm going to count up again. If I shade all 4, that's 8. I still need more. I need to get to 9 pieces. So I got to make another hole, cut him up into fourths. But now I have 8 pieces. How many more pieces do I need? Yeah, just 1. So I'm going to shade him. And now you're just going to count up. How many holes do you have? I have 2 holes. There's 2 holes. And I have 1 out of 4. So I have 2 and 1/4. Sorry, I'm losing. I'll write it up here. I'm losing. My notebook's getting small. So I have 2 and 1/4. How did that happen? I have 2 holes from here. And then I have 1/4. Okay. Now I'm going to flip my paper because I'm running out. What if I had, and I put it into a division problem? So there's my 9. There's my 4. Okay. And you can use any method to divide. I don't care. How many times can 4 go into 9? 2 times. 4 times 2 is 8 with the remainder of 1. Now, my answer was 2 and 1/4, right? That's what I had over on my other page. Okay, this is where it gets confusing for kids. The 2, this is your whole number. However many times it goes in is your whole number. Your 1 is your leftover. Your remainder is your numerator because that's still what you have left. This is still your piece. You still have it. It's still in your house. You just don't have enough for a whole. This guy always tells you what your pieces look like. Okay, so when you go to divide, that's what it's going to look like. So let's do it without a visual. Let's say 18/4. Okay, so what you would do is you could draw it or you could divide 18 and 4. Now we remember the numerator is always the dividend, the divisor is always the denominator. And if we paid attention to that in our fraction concepts, this should make sense. Okay, so I'm going to divide it the normal way. So 4 into 1, nope. 4 into 18, yep, 4 times. 4 times 4 is 16. subtract, and I have 2. Okay, so using this up here, how can I make my whole? Okay, this guy here, the answer, the 4, is my whole number, so I have 4. The remainder, look here, follow the arrow, is my numerator, so I have 4 and 2. This guy here is always the denominator, 4 and 2/4. Always and forever. Let's do another one. Let's go 23/5. Okay, so let's divide 23 into 5. I'll go back to partial quotient. How many times can 5 go into 23? 4, 20, and then subtract, and you get 3. What is your mixed number? Well, whatever you divide, however many times you say it goes in, that's your whole number. So you get 4 wholes. You have 3 pieces left over. So that's 3 over how many what made a whole? 5. So again, this number goes here, this number goes there, this number goes there. And if you understand our fraction concepts, the first few days we've been really working on this, on what all the numbers mean and represent, that's where I told you this would come in handy. Okay, this is what you have. You have 23. Okay, you have 23 pieces. You made 4 wholes from it. 4 times 5 is 20. So you have 3 pieces left over that are still yours. So that's still part of you. So the 3 is your numerator because you still have it. Your denominator is always your divisor. These two are always the same. He's always going to tell you what your pieces look like. Okay, let's do one more. Let's go 47/8. Okay, so again, you divide. How many times can 47 go into 8? Well, 8 times 6 is 48. That doesn't work. So 8 times 5 is 40. So you subtract, you have 7 left. Okay, so where's your whole? Your whole is however many times you divided. So I have 5 wholes. What do I have left over? I have 7 pieces left over, and I need 8 to make a whole. So my divisor tells me how many makes a group. There's 8 in a group. I have 7, so I don't have a whole. I have 5 and 7/8. Okay? The more you practice it, the better you'll get at it, and the more you understand fractions, the better you'll get at it. So hopefully this helps. If you have any questions, reach out.